building a DevOps kill chain, so technically how to hack into your organizations. A few words in the beginning. Maybe you know, around 10 years ago, there was a Stuxnet virus that was spread by USB pen drives. So in the Iranian nuclear plants, which were air-gapped, totally disconnected from the internet, they were still infected by the virus through the USB sticks that were planted by the Israeli agents. So the obvious mitigations for that was to block the USB devices, but usually that mitigation was implemented in a way that the computers, workstations of employees were protected against using pen drives, I mean the storage, but not other devices. Question to you, do your organizations, do they protect against using keyboards, USB keyboards? Because there are devices that still, they look like pen drives, but they are just virtual keyboard emulators. So these devices, they don't contain the viruses. They write the virus themselves. So you just plug it into your computer, and then it executes some commands by simply writing the code just as it was attacker's keyboard. And another one that is vulnerability on Logitech protocol for exchanging data over the radio. So you've got all of those wireless mouses and keyboards, and there is a vulnerability that was identified in July last year that you can actually intercept this communication between your wireless mouse or keyboard and inject random keystrokes into this communication. So you can practically be in a position of like 20 meters to the person. They are using the wireless mouse, wireless keyboard. You can just inject random keystrokes and you can write the exploit on their own computer, even if it's not connected to the, right? Okay. So the plan for today is that I will show you something that it's not really magic, how to go from the position on the internet to enterprise admin in your organization. A few simple tricks that maybe you'll be surprised it work. We'll see how it goes. Okay, a few words about me. I spend quite a lot of time in IT and security on a daily basis. So I do penetration testing, well, DevSecOps consulting and threat modeling, which is a new topic. Spend a lot of time in Poland, then Spain, Australia. So here is my mate, the gangsteroo. Now I'm back in Poland. I'm doing the penetration testing and consulting for banks, for fintechs, low airlines, etc. And recently, I've come up with this idea for instant threat modeling. So last year on DevOpsDays in Warsaw, I was talking about like a wide topic of threat modeling. That if you have number of security issues in time, it is quite logical that in the time, if you don't do anything, the number of the vulnerabilities will rise. But then you start from some specific level of number of vulnerabilities that are well, the consequences of the quality of your design. And of course, you can perform some testing to mitigate some of those vulnerabilities in the meantime. So the threat modeling idea focuses on improving the quality of design of your solution so that to minimize number of vulnerabilities that you have in your solution in the very beginning. And I started this instant threat modeling YouTube series that you can find at securing.b/ITM. It is 5-minute videos simply talking about different solutions, system applications or processes, and discussing answering three questions. Who can attack your applications? What can go wrong? And how technically this could happen? This is really easy, but you can go through those questions and come up with some great answers and come up with the security requirements for your solution, test cases, mitigations, and well, you have a metric for your security program. So the last episode is on outsourcing your application to third parties. We've got some more episodes there, like if you're implementing CAPTCHA, go and view the CAPTCHA threat modeling. If you're using video conferencing, then go to that one, Zoom, Skype, Teams, etc. And well, if you're using the SMS-based 2FA, go and watch the episode number 6. Okay, so well, threat modeling is something that you can apply to anything. Here is an idea of a password reset process. Easy. If you maintain an application, probably you have a password reset process, and you can model the threads, and you can find some vulnerabilities there. So once you have a diagram of your solution, what does it do? Then you can go to the threads, like enumeration of email addresses, or weak randomness of the password reset token, and then you can come up with mitigations for that one. So this is how you patch your applications before you even code it. And you can do threat modeling for anything. Like this is the remote voting in COVID times, remote voting on the sessions of the parliament. And you can find the threats there, and you can come up with some instant mitigations. So a really cool idea. I really recommend to watch that one. And now we will do, well, threat modeling, and I'll show you some easy vulnerabilities when it comes to DevOps and well, building the DevOps killchain. So let's hack it. Let's imagine that you maintain an application that is deployed in some infrastructure. Here is your organization. You've got some developers, they code the application. You've got some system administrators, and they maintain the infrastructure. Maybe you've got marketing department, which outsource your application to third parties, and then the fourth party codes the application, and the fifth party maintains the infrastructure. So here's the situation, how to hack it. And well, we have method one, default passwords. So what we do during, for example, a penetration test, we just enumerate all of the interfaces on the internet. We look for open TCP ports. We look for web applications that are deployed on HTTP services, etc. We take the first interface, we try the default passwords, we see what we can do, and then we repeat it for all of the interfaces. Sounds easy, but actually it provides great results. What are interfaces? If you look on your average application, you have tons of interfaces that are helping it running. So for example, here is a screenshot of all of the Apache application logos. Many of them, they expose an interface. Usually it is on the internet, sometimes on the internal network. And these interfaces sometimes offer much more functionality than intended. So if you're exposing like Red Hat OpenShift or Apache F-Link or Zeppelin or Ambari, and the accounts for these applications have default passwords, we can simply log into these accounts and perform some code execution by design. Because by design, those applications, they allow users to modify the runtime configuration, to add some code, add some Ansible code, and simply run arbitrary code on your servers. And then those servers are reachable from the internet, so that's the vector, but sometimes they are deployed, they're hosted in your infrastructure, in your DMZ. So then we can do some lateral movement inside your networks. Okay, method two, no passwords at all. And here is a very common case, like MongoDB by default doesn't offer any authentication. The same for Gluster. Maybe you're using the Gluster file system. If you just Google MongoDB hacks or Gluster hacks, you will see tons of messages like these ones from July 2020. 47% of online MongoDB databases are hacked, and the attackers are demanding ransom. So that's a bad case. If you have a MongoDB, enforce authentication, because probably soon it will be hacked. The same for Gluster. And then what happens when the attacker logs in and can control your database? They can not only encrypt it and demand ransom, but they can also download the sensitive data, maybe find some more information that will allow them to compromise the rest of your infrastructure. Okay, and now instant mitigation for number 1 and 2 is simply keep a list of all your interfaces on the internet. If you don't know how to do, just run nmap, scan for TCP ports, UDP ports, and make a list of all running applications for each of the web ports. Make sure that they have authentication and make sure that the passwords are not default. And well, tell your project owners and your system administrators, your DevOpses, that if they want to put a new interface on the internet, simply make sure that they have passwords that they are not default. Okay, method number 3, predictable passwords. Well, this is really similar to the method 1 and 2, but then we try common passwords. from the common passwords list. Predictable passwords like company123, April 17. This one is actually quite funny. I'll tell you a story. We've been doing a penetration test on some environment, and the system administrator's password was in the form of a month and a year. Let's say it was April 17. We performed the test, and then after a few months, they asked for a retest. So we're doing the retest of this system, and the administrator changed their password, but they changed it from April 17 to something like July 17. So really, this is still predictable. What we also do is a form of credential stuffing. We use passwords from public leaks, and there are a lot of public leaks in the recent years. Like you can find tons, you can find really tens of thousands or hundreds of thousands passwords on the internet. And there are situations where the domain admin password in the infrastructure used by the administrator is the same person's password from LinkedIn from 8 years ago. So that's bad. Predictable which kind of interfaces we try to attack with predictable passwords. Well, Outlook web applications, VPNs like Cisco AnyConnect, AWS consoles, or Jira exposed to the internet. And this gives some great results. Like if your organization has 100 employees or 1,000 employees, one of them will have a common or a predictable passwords. And practically what we need to get inside your organization is just one account, because once we use the VPN and we connect to your intranet, then we can hack all of the things that are not exposed to the internet, but they're on internal network. So instant mitigation number 3. Well, have a policy to make sure that all users have passwords that are not predictable, strong passwords. Two-factor authentication for those who can't. Well, practically it is best to enforce two-factor authentication for all of your external endpoints like VPNs, like Office 365, etc. Method number 4, vulnerable software. During this attack, we do the same. We enumerate all of the interfaces and we try to look for CVEs. So if we find Jira, we look for CVE on Jira. If we find, let's say, Apache Zeppelin, then we look for CVEs for Apache Zeppelin, and we try to look for exploits. And there are a lot of exploits. I remember one Polish IT security conference that their website was using Java struts, and then they had an obsolete version of struts, so practically anyone could hack their server through the vulnerable struts application. Instant mitigation number 4 is pretty easy, but it's actually a very complicated task. Keep it up to date. Well, you have a list of all your software, and you have a list of all dependencies of that software. So it is not only a web application, it is an application written in Java, and that Java is using the struts framework. So make sure that all dependencies are up to date, and it is quite a good idea to regularly scan it with some vulnerability assessment tools, just for open ports and for open vulnerabilities in that software. Method number 5, web attacks. Enumerate all web interfaces and test for web vulnerabilities. Sounds pretty easy, but well, there are techniques discovered like 20 years ago. SQL injection still exists even 18 years after its discovery. And that's pretty funny, but yes, we still find SQL injection in web application pen test in 2020. But there are a lot of other vulnerabilities like broken authentication, the XXE attacks, etc. They all still happen. That's just the OWASP top 10 security risks. But it is very common, and also within bigger companies like Facebook has a bug bounty program. Well, Google also has one, and Apple. And somebody found a bug in the Facebook web application. They earned like $20,000, but it was a pretty easy XSS attack that happens in a lot of other applications. So nobody is 100% bulletproof. There are vulnerabilities everywhere, so you need to test it. And that's the instant mitigation number 5. Well, first of all, don't maintain too many web applications, because it is hard to keep all of them secure. Introduce a proper secure software development lifecycle. make sure that you're running some penetration tests and make sure that that software is not vulnerable to some really not complicated low-hanging fruit attacks. Method 6, phishing. Here we have some Libyan prince that offers us $4.2 million. Well, obviously, probably you won't be faced with that kind of message. But what we do during like a professional phishing service simulation, we find all employees on LinkedIn. We're trying to find what the email address scheme. How do you form an email out of the name and surname? Then we set up a fake website, and we use a custom lure text, and we go back to method 3 because we now have the passwords. The proper phishing looks like this. For example, if a company is using Office 365, then they will receive an email that they have some 7 undelivered pending messages. They're blocked, and because there is some error in the synchronization, you need to click a link to read the message. And now a lot of people, like if you send this kind of message to 20 or 50 people, one of them will have some urgent case that they will expect some email, and they will think that that's this email, Office 365 sandbox. So they will go to that link. They will not look really carefully in the URL address, and they will simply put their password on your website, on the attacker's website. Now, once we have those passwords, we can go back to method 3, and then we can simply use this password as a predictable password because we know it. So we have access to all of the Jira content, all of the other content on the applications. Instant mitigation number 6. Well, you need to have two-factor authentication on all external interfaces, at least for VPN, mail access, etc. And well, security awareness training, regular security awareness training makes much sense if you have a lot of people in the organization, and especially when some of those people are not really technical, so they have less knowledge, less possibility to detect a mail as phishing. Method number 7, sensitive information. Well, so what we do once we successfully phish the user or we guessed a password to somebody's mailbox, we go through these compromised mailboxes, we go through Jira accounts and all of the other systems, and we look for more information that will help us to execute other attacks. So credentials, API keys, credentials to production systems, to test environments, internal information, sensitive files, anything that will be used to attack the other external endpoints, maybe the internal infrastructure, or simply to send a phishing email, but a very specific one, from a compromised mailbox to their colleagues. This is a very effective phishing. I can guarantee you that. Okay. So instant mitigation number 7, store all shared passwords in password managers. Do not store them on Jira. Do not post them on Confluence. Send all of the information, all of the files encrypted. So you need to set up a secure way to share sensitive information so that if your mailbox is compromised, or if all of the mailboxes in the company are compromised, there should be no passwords to any other system on that mailbox. Method 8, come closer. Well, this was before the COVID times. Well, you can still execute those attacks, but during the COVID times, we perform less and less of those physical penetration tests. So what we do is we come very close to the company's office, and we enumerate any wireless access. So think about guest Wi-Fi's, any WPA2 enterprise wireless mouses or keyboards. We see what we can do, and we go back to method 1 once we get access to the internal network. So one of those attacks was that old Samsung devices, old Samsung Android devices, they had this vulnerability that with the WPA2 enterprise, so a method of wireless authentication that requires domain credentials to log into the wireless network, those Samsung devices had this vulnerability to which allowed to steal the password hashes of those users. So once we have those password hashes, we can crack them. And once we crack them, we can use them either to connect to the internal network or to access any external endpoints like Office 365, like Jira, etc. There is also other way to get in, and guest networks. So if you have a guest Wi-Fi and it doesn't allow a proper separation between the guest network and your internal network, then you have a problem, because there are a lot of devices, a lot of servers, a lot of workstations that could be vulnerable on the internal network. One of the common targets for that, they're printers. So there are a lot of printers with default passwords. Go back to method 1. So there are the printers admin interfaces on the internal network that have the default passwords. And once you log into those admin interfaces of the printer, you can find that the printer is connected to AD or to LDAP with some accounts, and you can steal those passwords. So the printer uses it to authenticate the users, which swipe their cards, or which the users log in on the printer to print their files. But the printer itself authenticates in the AD, so you can steal the password, and very often it has excessive privileges in AD. So for example, it can access a lot of SMB shares, or simply be a domain admin on the network. So yes, instant mitigation number 8, protect wireless access. Don't allow your guests to access the internal network. And make sure that any devices that use the internal network, they are secure and at least they're up to date. Method number 9. Well, we come into you. So what we do is we either tailgate, we go after somebody, or we copy a MyFair Classic card. And this is really easy. So one of our colleagues from Securing, they have this business card that is not ordinary business card. Simply with a normal Android phone with NFC functionality, you can copy a MyFair Classic card onto that business card. It requires like a special empty card from China that you can buy for $5. But once you have this card, you can simply copy it with an Android phone. So what we really need to do is we need to find an employee somewhere on the corridor during lunch, swipe our phone near their cards, and then we can just access your network. Now, once we are in your internal network, there are a lot of things that you can do. You can go back to method 1, enumerate all interfaces, try to look for default passwords. Method number 3, try to look for vulnerable software. But there are also many other things that you can do. There are those beautiful Hack5 devices, or you can make your own with some Raspberry Pis. You can grab some screen from HDMI cables. You can use Wi-Fi Pineapple to hack the Wi-Fi networks. You can use the LAN turtle to man-in-the-middle connections on the Ethernet cable. There are a lot of things that you can do. Or use the USB rubber ducky to type and exploit directly to people's computers. But also what you can do is you can enumerate SMB shares. And usually there are a lot of SMB shares on the network that either allow anonymous login, or they allow login with the credentials you just compromised. So then on those network shares, you probably have a lot of sensitive data, maybe some backups, and maybe in those backups there are the passwords, or simply enough information to steal your crown jewels, which are probably your application source code, or financial data, or financial tokens to your bank. Okay, instant mitigation number 9, you need some network access control. Maybe it is 802.1x authentication on the internal networks, but simply protect internal network like it's external. So you shouldn't have any anonymous SMB shares. You shouldn't allow any null sessions. All of the files on the SMB network, they should have proper authentication, proper authorization practically, so that not all users can access your source code. Same for backups, same for all GitLabs, SVNs, etc. So we came to the last one, which is method number 10. getting the domain admin once you're in the internal network. And I really recommend you putting in Google how to get domain admin. And like the first five answers, they're really great, like domain admin in 30 minutes. It's not enough, then look for the fifth one, obtaining domain administrator credential in 17 seconds with some software. Go to that link, look what's there. Usually those attacks start from running responder .py. That's a Python software to inject some LLMNR over net bias responses, poisoning the workstations with the responses. Then you simply wait until there are some hashes there. Once you have the hashes, you can crack the passwords, or you don't need to, because sometimes you can delay them or use them in a pass the hash attack. The way this software works is that there are some protocols in the Windows network that are I'm sorry, protocols that need to be active to be backwards compatible with some older software. That's the LLMNR over net BIOS and SMB version 1, and then poisoning those requests make the victim computer, the victim workstation, to send the SMB authentication, which are practically the NTLM hashes or NTLM challenge responses, to the attacker. So the instant mitigation for that one is you simply need to turn off the LLMNR over net BIOS, turn off the SMB version 1, and you need to turn on signature on the SMB, so SMB signing. A very important one is that not too many users should have the local admin privileges, because once you have them, you can run tools like Mimikatz to dump the LSAS memory and dump the hashes of the passwords from the workstation. And practically, if a domain admin was logged in on a user's computer and that user has local admin privileges, they can simply dump the domain admin hashes from that machine. And introduce app whitelisting. Like if the users usually run just the browser and few scripts, then maybe there is no need, they should be able to run Responder or Mimikatz. Okay, cool. Quick summary, instant mitigations from 1 to 10 are that you need to know what you expose to the internet and don't expose too much. All of the passwords they should follow a strong password policy. So there should be no easy passwords, no default ones. If you're sharing passwords, do it securely over some good solution to send files in encrypted way. Two-factor authentication, wherever possible, your software should be up to date and you need to know all of the entry points to your network. So the internet, wireless, physical, Ethernet, etc. Follow best practices for applications and for infrastructure, and simply demand security from vendors and from the third parties if you outsource your software. And well, perform threat modeling. This is simply thinking about what can go wrong, and once you have this threat modeling of your solution, you can consume the output in great way. So like developers, the DevOps and sysadmins can implement instant mitigations. Project owners, they can enforce the requirements on the third parties. And well, the security department will have a metric of how bad are the vulnerabilities. The penetration testers will be more effective because they will have the test scenarios and the scope of the penetration test, and your clients will be sure that you've taken care of your security if you show them a finished threat model. I really invite you to the instant threat modeling series, securing.biz/ITM. And well, thank you very much.